So, continuation for the problem set number 4. So, to find the chair modulus of the bookcase, so there are the formula. So, S, which equals to chair stress over chair strain. So, which equals to F11 over A or LO over X. That FL, which is our tangential force, and 4 over area, and LO is the transverse distance over displacement. So our this tangential force is 50.0 Newton over the area is 2,700 centimeter and times 180.0 centimeter, which is our transverse distance over distance, and 2n over 9 centimeters squared, 2 over 9 times 10 to the raised power, 10 to the fourth power rather, and over centimeters squared. So S, or the chair modulus, 20 over 9 times 10 to the third power Pascal, or 2,222 Pascal. So F11, or the tangential force over the area, which is the 50.0 N, so which is our tangential force. So the area is 2,700 centimeter squared. By plotting the 5 points over 27 Pascal, so makaderive tag answer nga 185.2 Pascal. And for the transverse distance and displacement, so 15.0 centimeter over 180 centimeter, so 1 over 12, so that maka-derive the answer, ito na siyang i-simplify or i-multiply, we can get the final answer is 0.083. So, problem set number 5, example 15.2, page 751, determining the equations of motions for a block and a spring. A 2.00 kilogram block is placed at frictionless surface. A spring with a force constant of K, which equals to 32.00 N meter per meter, is attached to the block, and the opposite end of the spring is attached to the wall. The spring can be compressed or extended. The equilibrium position is marked as X, which equals to 0.00 meter. Work is done on the block pulling it out to X, which equals to positive 0.02 meter. And for the block is released from the rest of the oscillates between X, which equals to positive 0.02 meter. And for X, which equals to negative 0.02 meter, the period of the motion is 1.57 seconds. Determine the equations of nation. For the given is letter A. Letter A, which equals to positive 0.02 meter, and for T, or time, 1.57 seconds. So, kaning A, which is our amplitude, and for the phi, 0.00 rad. For the solution, we need to see first the angular frequency to 2 pi. So 2 pi over the time, which is our time is 1.57 seconds. So that ato rin siyang makaderive din tag answer nga 4.00 seconds to the raised power of negative 1. And for the Vmax, or the maximum velocity, is 0.02 meter and 4.00 seconds, which is our weight, and then raised power of negative 1, so that maka-derive the answer 0.08 meter per seconds. And for our acceleration, maximum acceleration, 0.02 meter 4.00 seconds to the raised power of negative 1. So, raised power of negative 1 squared. So, makaderive po tag answer nga 0.32 meter per second squared. And for the equations of position of the functions of time, velocity of the mass oscillating is harmonic motion. So, motion, time of the velocity, maximum acceleration cos or cosine, plotting the value, the value. So, equations of motion. So, auto na siyang i-plot, guys. So, x is time, over time is a cos of wt plus phi, or which equals to 0.02 meter, which is our amplitude. So, muna siya amplitude, and 4.00 s or seconds negative 1 to the raised power of negative 1. So, maroon siya, guys. Thank you.